Let's solve for the unknown of this given equation. We have 7 minus x is equal to 3x plus 2. Take note that both sides contain the set unknown and both sides also have constant. So we have here multiple methods to isolate the unknown on one side of the equation. I might be able to present to you two steps here, but ultimately if you're going to follow the correct processes, you will end up with the same result. Let's start by copying the equation here. 7 minus x is equal to 3x plus 2. The first method I'm going to show you is by simply removing 7 here, because I am deciding that the left hand side of the equation will have the unknown. 7 minus 7, that's 0. But do the same thing on the other side as well. Hence, I will have here negative x is equal to 3x. 2 minus 7 is minus 5. The next here is for me to remove the term with x on the right hand side so that this side will only have constant. Since it's a 3x, I will subtract here 3x. 3x minus 3x, that's 0. Do the same thing on the other side. This method will involve a lot of negatives. That's why you really need to review your operations in integers, such as this. Negative 1, understandably. Minus 3x, you have negative 4x. And the other side will have negative 5. And when you will divide both sides by negative 4 to make this 1, doing the same thing on the other side, you will have the result for your unknown, which is equal to the ratio, which is positive now. Negative divided by negative is positive, 5/4. Of course, we will accept fractional results here. At the same time, we will stick with this improper fraction instead of mixed, because if you're going to come up with it's mixed like 1 and 1/4, or even a number in with decimal notation 1.25, it's good, it's correct. But once you will apply it on checking and other processes later on, it will be very difficult for us to do that. Before checking, let me show you the other method. Let me recopy the problem. 7 minus x is equal to 3x plus 2. If you don't like the first method that involves negatives, because some of us will have problems with dealing with this, let's remove x here instead of 7. But x here is minus x, so we will add x here. So negative x plus x, 0. Do the same thing on the other side. You will have here 7 is equal to 3x plus x is 4x. You have here plus 2. This would mean I am choosing the right hand side for the side with x, or the unknown. In short, I will be subtracting 2 here, and I will also be subtracting 2 on the other side. 7 minus 2, I have here 5 is equal to, of course, this becomes 0. What I have now is 4x. To finish, divide this by 4, divide the other side by 4. You will have the result, which is 5/4 equal to x. Now, applying symmetric property, the property which allows us to interchange both sides of the equation without altering its sign and value, you will just have the same value as this. So they are just the same. Nevertheless, both methods gives us the value of the unknown being 5/4 as improper fraction. This time, we are going to do the checking. And take note, we will have fractional value for our unknown. So you really need to remember the operations on fractions together with its application with a rational number, or specifically an integer. Our x here is 5/4. As mentioned, this checking is not a necessity, but for us to practice and of course for us to have a way in checking our answer, we will do this. So we will just simply substitute 5/4 to x. So 7 minus 5/4. On the other side, you have 3 times 5/4. And the result of that will be, that's 5/4. and the result of that will be added with 2. Since this is checking, and our goal is to only come up with a balanced equation, let's have question mark here. Take note that if we are going to add an integer and a fraction, we can represent this integer as over 1, okay? And the LCD there is 4. 4 divided by 4 divided by 1 is 4, times 7, I have here 28. 4 divided by 4 is 1, times 5, I have here 5. Minus, that's the operation. On the other side, still question mark. This again over 1. So 3 times 5 is 15. Over 1 times 4, 4. Plus 2. So this side now will become 23/4. How about the other side? LCD. Again, this again over 1. So LCD is 4. 4 divided by 4 is 1 times 15. I have here 15. 4 divided by 1 is 4, times 2, I have here 8. And the operation is plus. Even if it's too obvious, simply continue with the process until you reach this. Your left-hand side is 23/4. The right-hand side for the numerator, 15 plus 8, that's 23. And then your denominator is also 4. Once you reach that, check mark, means you have satisfied the equation, and the value for the unknown, either in this form or this form, being 5/4, are the correct results. Join us to the next adventure involving the unknown.